domain and range of a function. So first off, when we talk about domain is all of the possible x values that you can put into the function. So domain goes with your x values. So then the range is all of the possible y values that you can get from a function. So we're going to start by looking at what this means in terms of graphs and some ordered pairs, and then we're going to move on to what it means in terms of equations. So remember, domain is x's, range is y's. So for this first one, the domain is all the possible x values. Notice, remember, x's are horizontal axis, and this keeps going on forever. So what that means is it's eventually going to hit all positive x values over here and all negative x values this way. And notice even at, like for example, 1/2, there is an x value of 1/2 because the graph is continuous. It's always going. So the domain for this is going to be all real numbers, or from negative infinity to infinity. It's going to hit every possible x value we can. Now for the range, these are your y values. So for this one, we want to look how far up and down does the graph go. Notice the graph is never below 0 and never above 2. So that means the lowest possible y value this graph hits is 0. Highest possible value, it's 2. And notice it actually does hit both. It hits 0 here, here as it goes. Hits 2 here, 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 and keeps hitting it as it goes. So it hits 0 and 2. So we put our boxes or brackets around it to include 0 and 2. It actually does hit those. And then using our vertical line test, notice no matter where we draw a vertical line, it only hits the blue graph once. So this is a function. Now looking at the second one, our domain is just our x values. So notice the smallest x value that the graph hits is -2. Everything to the left of it, we don't have a graph. So it actually hits -2, so we want to include -2. And then notice it keeps going to the right forever, so it's going to go to infinity. And remember, infinity always has parentheses. Now our range. How far down does the graph go? Notice this just keeps going farther and farther down. It's going slowly, but eventually it's going to hit all our negative y values, just like this one is rising slowly, and eventually it'll hit all of our positive y values. So you have -infinity to infinity. Now let's check if it's a function. Notice we can draw multiple vertical lines that hit the graph in more than one spot, so it's not a function. And that's due to the vertical line test. Same ideas on these. So for this first one, we're going to determine domain and range, and then decide if it's a function. So notice this first one, the domain is our x's, and notice that it's very slowly widening up down here. So eventually this side's going to hit all of our negatives, x values, and this side's eventually going to hit all of our positive y values. It's going to take a long time, but eventually it does get there. So it goes on forever in both directions. Now our range. Notice that these keep going down forever. So our lowest possible point is -infinity. But notice the graph stops at a height of -1. It doesn't go any higher. So that means it only goes up to -1. And since it hits it, we've got a bracket. test for the vertical line test, no matter what we do, we'll only cross the graph once. It is a function. So now the second one, domain. Domains are x values, so if we look here, notice this is going to keep going to the negatives, this is going to keep going to the positives. Eventually we're going to hit every possible x value, so we hit everything, all real numbers. Same idea with range. It's going to keep going down, so eventually we'll hit every possible negative y value. Goes up, this keeps going up. Eventually we'll hit every possible positive y value. Last but not least, let's look at vertical line test. No matter what we do, any vertical line's only going to cross the graph once. So it is a function. First one. Domain, just our x values again. So notice the smallest x value that this graph hits is -1, and it actually hits it. So it's inclusive. And the highest we go is 5. It actually gets to +5, so we use our brackets. Now range is our y values. The lowest possible y value down in here, so we get down to -2. Highest y value is up here at 0. We hit it, so it ends at 0. Notice we can draw a vertical line here. It hits the graph twice, so it's not a function. Now with these next two, which are sets of ordered pairs, we're not going to use ranges anymore because we have specific numbers and only those numbers as our options. So our domain is just our x values, so we just want to go ahead and just literally list your x values. Notice it's not a range, because even like for example 0 happens to be between here, but we don't actually have an ordered pair with a 0, so we want to use only what's given. So then our range, just our y values. If you want to write the 5 twice, you can. If you just want to write like this with 5, 6, since there's repeats, that's fine. Now notice each of these x's are paired with one and only one y. So it is a function. Now coming down to this one. Once again, since we've just got a set of ordered pairs, just list your x values. And I don't care whether you go in order of smallest to greatest. I tend to just go in the order they're presented. Same thing with range. Now for this one, notice we've got a -3 paired with a 4 and a -3 paired with a 7. So it is not a function because we have one x value of -3 that has a y value of 4 and a y value of 7. So now we're going to switch to determining just the domain of different equations or functions. The easiest way to start these is to actually look at it backwards and kind of opposite and say, okay, are there any x values that we can't have in this function? So another way of thinking that, is there any x value that will make this whole thing undefined? When you figure out that value, if there is one, then that actually means x can be anything except that one value or two values or 3 or whatever it is. So for these, that's how we're going to walk through them. So looking at this first one, remember what makes a fraction undefined is if we have a 0 in the denominator. So notice this one, if x is 0, we would have a 0 in the denominator, which we can't have. So that means the domain is x can't be 0. And when we write it like this, what this means is x can be any number except 0. That's what it means. And when you write out the domain, it's a lot of times it's going to be a lot easier to figure out what value it can't be instead of trying to list all the values it could be. Because think about, if x could be anything, you can always divide 2 by any number except that 0. So now for the second one, once again we want to figure out when will our denominator be 0, and that's the number it can't be. And when we solve this, we'll get x is 5. But remember, that's the value that makes this denominator 0. So we actually want to write the domain as x can't be 5. So it can be everything except that value of 5. Now this last one, notice there's only one fraction here. And this 4 is the denominator. It's never going to change. It's always that 4. So that's never going to be undefined. So what this means is we can pick any value of x we want, and we're going to get a y value. So what this means is any number we pick is going to work. So all real numbers are going to work. So we're going to go through the same thing here. So we want to start by looking at what would make that denominator 0. Remember, back to factoring. So that means if x is 7 or if it's negative 7, our denominator is going to be 0. So what that means is x can't be either of these. It can be anything else, and this will give us a number. But if we do 7 or negative 7, we're going to get something that's undefined. So now this one, we don't know how to factor it. Quadratic formula is not going to really help us. Square root property is not going to help us. But I want to point one thing out. Notice x squared. This is always positive. And then we're adding adding 16. So no matter what, we're always going to get some sort of number down here. This is never going to add up to 0 because you can't add a positive to 16 and end up with 0. So this is another case where it's going to be all real numbers. This last one, we want to go ahead and factor it. I do recommend that you keep practicing those factoring skills and go through all those steps that I just skipped over. Think back to what we did in chapter 5. So what this means is that x can't be 1/2 or negative 3, because either of those values will make that denominator 0, which we can't have. One thing I do want to point out, when you're writing the domain of an equation, make sure you put not equals to, because that makes a big difference between x is equal to that number.